Hi, everybody, and welcome to today's webcast, Composing Unbreakable AI Workflows. Our presenters are the co-founders of Bauplan, Jacopo Tagliabue and Ciro Greco. For those of you not already familiar with Bauplan, it's a platform that greatly simplifies and enriches AI data engineering. And co-presenting with Jacopo and Ciro are the co-founders of DBOS, Chan Lee and Peter Kraft. And for those of you who are not familiar with DBOS, it's a platform that makes the software you build resilient to failures, programming errors, and cyber attacks. Our agenda today is going to start with Bauplan. They'll show you how to build and deploy with Bauplan. And following that, Peter and Shen will talk about how to make workflows and data engineering work done with Bauplan durable and observable with DBOS. So without further ado, let me turn things over to Jacopo and Ciro.
So thanks everybody for joining, and of course, thanks Andy, Peter, Chang for co-organizing this. We opened this webinar today by kind of like guiding you through the automation work that we've been doing together with our customers in the data engineering space. We call it the agentic lakehouse. I understand there's a bunch of marketing bullshit in this title, but the general thing is a very, very practical problem, which is a lot of us work with data. Some of you may be data engineer, some of you may be adjacent to your colleague in data engineering and data science. And a lot of the work that data engineering and data science do is kind of repetitive and will be better off. We will be better off if that could be automated, so we can all move up the stack of the value chain and actually do more interesting stuff. Okay, and so today, in our very, very brief overview, we try to give you the lay of the land of what is the automation in this kind of new design space that the AI is opening, and of course, a bit of a plug of like Bauplan as particularly suited to automate this part of the workflow, and then we're gonna leave our friend at DBOS to explain how to make all of this kind of like reliable, durable, and all sorts of things. So again, for those of you familiar with the engineers, and also for those of you who are not, this is kind of like the 9 a.m. Screen of many of us that work with data, right? This is in particular the Bauplan job UI. If any of you have worked with Airflow, you know that the vast majority of our work with Airflow is staring at this screen and see all the things that are red and kind of like sweating and trying to not try to change job and kind of like have nervous breakdown and so on and so forth. So what is the problem? The problem is that when you do that engineering, you kind of like run a lot of jobs. You run a lot of jobs asynchronously, so you have this pipeline that runs at night. Again, even if you're not familiar with it, I'm sure somebody in your company is. And the idea is that you kind of schedule them through some orchestrator, and some of this job will complete, some of the job will not complete. And it's a good question of like, when I wake up every morning of like, how do I debug all of this? Like, why do you have to spend the first few hours of my day going through all of this thing one by one and figuring out what was wrong and what's not? Would it be nice if my day, instead of starting like this, was starting with somebody else has already done this job of figuring out what's working and what's not, and would kind of like prepare a summary for me and say, okay, this didn't work, and I think this is the cause, so that I can actually start my day with a coffee and a much better mood than what it actually is. Up until 3 months ago, I know everybody's already tired by the AI, the AI pace, and everybody is fatigued about AI or LinkedIn and all of that. But if you pause for a second, I've been doing AI for a long time. I'm much older than what it looks like. I've been doing AI since before it was cool. If a year ago people told me that somebody will try to automate this, I will actually call this a complete dream of like, no, this is impossible. It's never going to be possible. And the point of this talk is not saying that this is 100%, that the job of data engineering can be 100% automated today, but there are incredible amount of opportunities to make things more reliable, more streamlined, that even like 6 months ago would be complete fantasy. So what do data engineers do? Again, for those of you who are not familiar, you have typically two things that you need to do to fix that dreaded red jobs in your job listing. you need to be able to check metadata. And by metadata, it means you need to check things that are not related to the data itself, to the tables in your lakehouse. You need to check, for example, a schema. Somebody would have, drop a column. You need to check the pipeline that was run. So, for example, somebody may have installed the wrong package, or they have updated pandas package, but they didn't change the pandas API, which may have changed between major versions. You'll be able to do monitoring analysis, like you need to go in your job list, figure out what was wrong with that job by checking, for example, what's printed by that job, and so on. And this is one big part of data engineering. The second part, of course, is doing work with the data itself. Somebody may say that's the most important part, which means that you need to interact with the tables that have been prepared by other pipelines, by ingestions, or by your colleagues, and you need to somehow produce business value by writing new pipelines that actually generate tables that downstream system, a dashboard for your executive, a machine learning model will actually use. So the life of a data engineer, that starts at 9 a.m. with coffee and with a lot of, red semaphores to check, is kind of always torn between these two big things. Checking the metadata, the infrastructure, and the telemetry, and actually doing the data engineering job of building pipelines that actually get data from point A to point B to point C. So if we want to automate this, we need to be able to do two things. We need to be able to read stuff, and we need to be able to write stuff, okay? And of course, as you can already figure it out, giving AI access to reading stuff, of course, is terrifying to a level, but not that much. Worst case, you're going to read something you're not supposed to, which I'm not saying is good, but it's, okay. But of course, writing is really terrifying. Like, if you think about how many mistakes, Claude or ChatGPT can do, it's kind of terrifying, the idea that you give a write access to your lakehouse. Like, sure, we're trying to solve our problem, waking up at 9 a.m. with that list of jobs to fix, but we do want to create more problems than what we're fixing. So what is a setup that, will allow you to do that look like? There's you as a data engineers and, as a data practitioner, you're going to have an agent. An agent, for the purpose of this talk, is a fancy term that means a while loop with some tool calling. Okay, but people call it an agent, but it's fine. So, but it's not a fancy thing. Is you can write it in like 100 lines of code or less if you want to start from scratch. Okay. The important part is that the agent will have some, LLM reasoning capabilities by connecting with one of the famous LLM, either open source or closed source, and then it will be able to have operation, both read operation and write operation in a lakehouse. Okay, and this is the kind of like standard Bauplan configuration. What is cool about Bauplan and not another lakehouse? Like, you can imagine trying to do this with almost any other combination of things. Like, you can have, again, an MCC server that is the Bauplan one. You can swap it out for an different FTP server and lakehouse. And the peculiarity about Bauplan is that Bauplan is an entire lakehouse in a few APIs. So Bauplan is the only place on the planet that when you run something with Bauplan, when you build a pipeline, when you get those job report that we saw in the beginning, all the things that happens inside of a job are actually exposed with very simple, easy to use API. Both in the read side, converse with your data, chat with your data type of thing, text to SQL type of thing that I'm seeing you're on LinkedIn every day. And again, that's okay, but it's kind of the boring part. And on the right side, so Bauplan allows, very, very easily to write code that actually transform hundreds of millions of rows, do quality check, do data ingestion at scale, just by passing a few parameters in the right place, okay? Bauplan was built with the idea internally that we want interns to be able to write production code in a day. And as somebody said recently, Matej, which is, I think, an advisor of our friends at DBOS, Matej, the founder of Databricks, had a VLDB keynote 3 days ago, something like 5 days ago, and he said that agents are caffeinated interns, okay? And that's his way of understanding agents, which I think is a good metaphor. And why does it matter for us? Because Bauplan is very easy to use for interns, and so, by design is also very to use by caffeinated interns, and there's nothing else you need to teach them. So how can we do that without being scared? How can we do it without, creating massive disruptions in our system? Remember, the demos or chat with your data are nice, but they don't really move the needle. They're not going to fix your pipelines. How do we do this in a way that actually makes us live better and not worse? And the answer of Bauplan is the built-in security that the platform has. So there's a million ways in which you can imagine working on data. And the way in which Bauplan does it is by basically combining two main ideas. One is Git for data. So if you're familiar with Git, imagine the same type of flow, but on your data. So you can see here, there's a main branch, which contains all your tables. You can isolate all the changes in a branch, for example, for an agent, and then you can decide if you want to merge or not. So nothing ever happens on your data lake that is somehow not sandboxed by definition. So if you want to let loose an agent on your data lake, do it, because the worst thing that can happen is that a branch gets created, the branch is useless, you can kind of delete it, start over, and we're kind of back to square one, but nobody's any worse off because of this. The second idea is that compute isolation. Every Bauplan pipeline that you run are just small functions that, again, they're trivial to run and to write by interns, either humans or agentic. And these functions are completely isolated. They have declarative packages, and they're completely sandboxed from the internet. Meaning that, whatever the agents run, they cannot access the external intern because the communication with the lake is all mediated by the platform. So there's no way for them to go outside of this box. And you can even, if you want, whitelist the type of packages that these agents actually can import in their function. Which means that the second big security or like trust problem that people will have with agents is sort of like, removed. Like there's no way for an agent to run adversarial code or to run untrusted data from the internet inside of a function in a pipeline. So if you combine these two ideas, you have like isolation on the data side, isolation on the compute side is kind of exactly what you want to, again, sleep better at night and still let loose these agents to do the job that, you don't want to do at 9 a.m. in the morning with your coffee. So how does it look like as an architecture? There's the agent loop. Again, the agent loop is just a big while loop. You prompt your agent, you prompt your agent with something, hey, we're gonna see an example later. Hey, can you load this data into this table? There's gonna be an LLM, which is gonna make, some plan. The LLM is either gonna produce some reasoning step or it's gonna produce some tool step. The tools are gonna connect you to Bauplan, which is gonna do the actual lakehouse operation. And the result is gonna be fed again into the reasoning model, into the LLM, okay? And then this loop is gonna go on and on and on until some stopping conditions, right? For example, when you're loading a table, it's like, hey, please load this table into my lakehouse and check that the data quality of this table is good. For example, check there are no nulls. And then once the model thinks that it's finished, it's gonna say, okay, this is the branch, check the branch, and then if you want, you can merge. And so working with agent becomes kind of like managing your interns in a practical sense. You manage PR, you manage branches that other agents open instead of doing the work yourself. And of course, we highlighted here some dotted lines between LLM reasoning, calling the tools, and the tools calling Bauplan. Why? Because these are all operations that can fail. And so the question that I'm sure our friend at DBOS will tackle in a minute is, can we make this durable? Do I need to start over again if one of these operations, which is technically an operation that can fail because it's a call to another service, actually fail? What do I do? How is this loop kind of resuming without losing consistency? And this is a very, very big problem in the inner side of the loop. Okay, but if everything goes well, either because it goes well the first time or because you can, build it reliably with DBOS, at the end of the day, the agent will be able to figure out this import problem and is gonna kind of return a branch for you. So just to conclude a very practical example, I'm gonna show the write audit publish pattern in this kind of like automation flow. And write audit publish pattern is kind of like a mouthful, a complicated terms in data engineering for a very, very simple idea. And the simple idea is as follows. When you ingest new data into your lakehouse, before telling every system downstream that the new data is available, you should check that the data is a good quality. Okay. And again, this seems like a trivial thing to say and a trivial thing to do, but it's all but trivial in current platform because lakehouses are a massive distributed system, and it's kind of very hard to piece together all these pieces in a way that actually makes sense for the developer and for the downstream consumer, okay? And so if you think about how doing write, audit, publish in the agentic system, what the agent should do is you should create a branch, we sandbox your changes, okay? And then you write your data is the right part, okay? So you take the data, you write the table, you do some quality test, so you audit, and then if the quality tests are okay, you can just merge back, okay? you can imagine again, this is a kind of like a data version of what many people do in CI/CD for code. So you try, before merging your new feature branch, you kind of like run automated tests, and then if they pass, you merge. Okay. But imagine this, instead of being like a tiny thing that runs in a GitHub action, like it's for code, this is a massive distributed system over object storage that somehow needs to be managed by, for example, in this case, Bauplan. And what we want for an agent, remember, the agent is an intern, it's a caffeinated intern. The agent cannot handle that much complexity. So all this distributed system complexity and scalability needs to start to be abstracted away in a way that the agent can just reason with it with very high level API. So this is an example of us, and I'm gonna comment through is asking on Slack. So you can connect any interface you want to an agent. For example, we connect a Slack, and we're gonna basically ask the agents to import some Asbury tables starting from our S3 bucket. We're gonna tell him how to name the tables. We're gonna say, hey, please run the quality check, and finally tell us if all this goes. So on the left, we have the real Slack. On the right, we have basically the logs generated by the agents. The agent is run in this case with small agent, which is an open source framework. It doesn't really matter. And you can see here, again, the glorified while loop. You see there's like step 1, step 2, step 3. Every part of this is basically one pass of this loop where the agent tries to figure out by combining reasoning and combining tool calling, so MCP calls to basically Bauplan and the lakehouse, how these things actually work. We're gonna share this later with everybody, so there's no need to go into the exact detail on this. But if you see this, you're gonna see the agent, for example, in this case, creating a table, importing the data, and you see that in most cases, the agent succeeded the first time. The APIs are so trivial to use that even an agent with basically no knowledge whatsoever of the lakehouse can actually make quite an impressive progress on this. The thing that I find the most cool actually is when he makes some mistakes, and then when he reason again and try again and actually succeed. If you run this, you can run this and many more complex operations already today on the Bauplan Lakehouse with whatever agent framework that you like and with whatever LLM you like, and get kind of like, kind of impressive result into that sense. Here is basically running, data quality table and, trying to make sure that there's no nulls. The system does everything for you. And at the end of this, we're going to just keep a bet. It's going to basically reply back on Slack, and this is what happens. So it's going to say, hey, I done everything you asked for me to doing. There's an import branch that is called Cheer Ingestion. That import branch, again, you can check it like a PR. You can verify that what I said is correct. I did all this quality check that you asked me to do, and all of them passed. Okay. I recommend to double check. I recommend to double check that the test actually passed. And for them, of course, we can refer to observability tool like DBOS to verify that all the tool calls and all the answer of the agents are actually what they say they are. But that said, this is a completely different way of working compared to the one we're used to. And it's kind of like the dawn of a new era. Again, nobody says that the entire job of data engineers can be automated, but there's a lot of chores and a lot of things, like, for example, checking your pipelines at night or ingesting new data that can now be done proficiently because of the combination of AI and kind of very good infrastructure that supports on this. And on this, I let our friend at DBOS take over and tell us about all the inner loop of all this.
Thanks, Jacopo. We'll turn things over to Peter and Shen now. And if you have questions about any the materials today, feel free to enter those into the Q&A box, and we will get to those after Peter and Shen. Thank you.
Awesome. So, yes, we wanted to quickly talk about what DBOS is, how it works, and how it solves this durability, this reliability problem that Jacopo was talking about, and how it helps you build really unbreakable AI agents. So, just to give you a quick overview of what the actual does the screen share all look good?
Yep.
Yes, just to give you a quick overview of the problem space. Like, the main problem we're trying to solve is that any real application, it's really hard to build reliable applications. That's especially true for AI agents. Like, let's say you want to build an AI agent that takes an action in the real world, like transferring money or processing refunds. You have to deal with failures, potential failures everywhere in the stack. And the agent itself, of course, in the agent's connection to the LLM, in the actual refund process, which could time out or which could fail in any place. And you have to make sure this process is actually reliable because you're moving around real money. Why can things break? Things can break because of process crashes. Things can break because external API calls time out or are rate limited or have outages. Things can break because users take too long to respond. And of course, if you're running at scale, if you have, say, data pipelines like the ones Jacopo was talking about, processing hundreds of thousands of documents for agents, or you have agents performing many tasks in parallel, then failures become far more likely. So normally, if something breaks, you might want to restart it from the beginning. But for data pipelines and for agentic operations, that's not always a good solution. If you try something from the beginning naively, you can often get data corruption or data duplication. You might transform data one too many times and end up destroying it. If your workloads are large, you can also waste a lot of compute resources or a lot of time retrying things. If you're retrying an 8-hour pipeline with 1,000 steps processing 1 million documents, well, retrying that from the beginning if it breaks halfway through is not a good use of resources. So DBOS tries to help with that through durable workflows. And the idea behind workflows is that you can regularly checkpoint the state of your program or your agent. So you write your program or agent as a workflow of steps, and you regularly checkpoint that workflow. You checkpoint the outcome of every step, so that if something breaks, if something fails, your workflow can always resume from its last completed step. And the good analogy we like to make is like save points in video games, where if something breaks, you just reload your last save, recover from your last checkpoint, and keep going. DBOS implements durable workflows as a library. So all you have to do, and it's a library totally backed by Postgres. You annotate workflows and steps in your program, where it is on your existing infrastructure. And as that program runs, the library checkpoints workflows and steps in Postgres so that if something goes wrong, it can always recover from the last completed step. So here's what the code actually looks like. You write normal code, Python, TypeScript, Go, Java, add the annotations, and the library does the work for you. So I'll turn it over to Chan to talk about how DBOS can be integrated into your existing agents or into popular existing agentic frameworks.
Yep. Thanks, Peter. So this is the news today. We just released the Python AI plus DBOS integration. So now you can build durable agents with DBOS and Python AI. What I really like this integration is that it's super easy to use. If you're already familiar with Python AI, it's an agentic framework that allows you to build generative AI agents really easily. And as Jacopo said, it's just a giant main loop. Well, in the loop, you ask LLMs, what should I do next? LLM will respond to you with a list of tools you should call, and then DBOS will call those tools reliably with DBOS step, or you can use with DBOS queues. So if you please check out this integration. Yeah. And then, so how it works. So the nice thing with DBOS is that DBOS supports both sync and async Python. So if you're already using sync or async Python, if you're already building some agents, then you can simply add DBOS to it without restructuring or re-architecting your program. And then, at least for this integration, we made the agent's main loop as a deterministic DBOS workflow. So this is quite simple. And then for external model calls and MCP communication, we automatically wrap them as DBOS steps with retries. So because we need to do everything, if any function has external communication or I/O or some non-deterministic code, we have to wrap it in step so that if we retry it, we can retry the entire step automatically. And then for individual tools, you can decide how to handle them with DBOS. Like instead of automatically wrapping them as DBOS step, you can choose to use a DBOS step, or if you're confident that your function doesn't have any external IO or determinism, you can just use your normal function tool. So this avoids a checkpoint overhead because each step will actually incur a database write. This is inevitable for like all the durable execution engine because you have to persist your output to the database, to our data store. So if you're confident that you don't need that overhead, DBOS allows such flexibility to compose your workflow. And finally, you can also, from within your tool function, you can also enqueue background tasks that say, okay, I'm not going to wait for this background processing to finish, so I'm going to just dispatch it to some other workers to process asynchronously. So the thing is with DBOS, it's really flexible. Like as someone commented, DBOS is not a super opinionated framework. You can use it just as a library in whatever way you like, and then we can guarantee the entire agent is durable. So if we move to the next slide, this is roughly the durable agents reference architecture. So so where DBOS lives is inside your app server, in your app's process, and DBOS is just a library. And then whenever your client sends a chat request, either through HTTP, RPC, or Kafka, it lands to your app server that triggers the main agent's run loop, which is the durable workflow. And then the agent's loop will contact external services like your LLMs, or even it will contact Bauplan, for example, to manipulate your data. And then each step can be reliably retried if something happened. And then if something goes wrong, for example, with Bauplan, you can easily revert the change. So everything is programmatic and everything is automated. And then there are also queues, cron jobs, and messaging communication that is really, really helpful if you want to do asynchronous tasks, or messaging can be useful if you want to send a message, for example. Well, if you want to implement human in the loop pattern, where you publish something like events, and then the human can review and say approve or reject, and then it will send the signal back to your workflow and say like, okay, now my next step is going to be based on like the choice from human input. And then at the bottom of the stack is the database. So the nice thing is we currently support both Postgres and SQLite in Python. So if you use SQLite, you don't even have any external dependency. You can just have your application server where we automatically checkpoints the workflow and step state and queue state in the database. So your app is a self-contained, reliable process. And if you want to run your agents at scale, then you will use Postgres, where you can deploy many, many agents in a distributed fashion. And then all of them will work together to solve the durable execution and agent problem. Okay, next slide. And then there are a lot of use cases. So you may ask, why do I want to use durable agents? Because if your agents are going to touch your database, are going to create a table or destroy the table, or destroy a database or delete a table, then you want to be able to observe what's actually happening. And if your agents are going to have a sequence of tasks, you want to guarantee that all those tasks will eventually finish. For example, if a task is going to do some research on the web and then send an email to the user, you want to make sure the users will always receive an email exactly once, because if you don't send the email, users may think, okay, your app is not working because I didn't receive anything. If they receive multiple emails, they may think, okay, it's really unprofessional. Why did I receive multiple of this? So you want your agents to survive any failure conditions. You want it to survive any restarts or app redeploys, stuff like that. And then the second use case is that nowadays a lot of AI agents are really long running. Like the agent loop can last for like days or even months, for example, to keep track of the user progress on, for example, if you're onboarding a user or doing some online training, you really want the agent to be able to keep track of the entire life cycle, so that task can be really long running, and you can have a lot of background jobs, and you often will involve human in the loop, and you want to make everything traceable and observable and replayable, so that if something crashes, you can resume, and if something goes wrong, you can debug by replaying it. So, and then the final use case is sometimes people usually put agent and data pipelines together. As Jacopo said, like one agent can launch hundreds and thousands of parallel tasks in the background, and you really want something to orchestrate that. And existing task queues may not be enough, because sometimes when you submit tasks to queue, you don't know whether it's finished or not. But if you use durable task queues like DBOS, you can always guarantee things will finish. So actually, we have a very fun demo. So Peter will show you why you want to use durable agents.
Yeah, so I want to walk through the code of one particular durable agent, both to show what it looks like and also how easy it is to add, DBOS to your agents. This particular, so Chen's talked about our Pydantic AI integration. This particular agent's actually just been built directly on top of the OpenAI API. Like DBOS will work with anything. So the code of the agent this is a deep research agent. What it does is you give it a topic, and it iteratively researches the topic, generating more, doing a web search for topics for subjects related to the topic, then synthesizing that into a report, then iterating on related topics until it's built a final report. And as you can see, the amount of code you have to add to turn this, this research agent into a durable agent is minimal. You just annotate the agent's main loop as a workflow, and you annotate each individual step, like researching a query or generating the next topic or synthesizing a report. You annotate those as steps. That's really all you have to do to make this agent work. So what I'm going to do now is demo this to you. And because I'm either brave or stupid, I will demo this. I'll actually do a live demo of this. So we're just going to take this agent and run it. So this agent is going to research. This is going to research AI agents on Hacker News. So it'll create a report of what Hacker News' opinion is on AI agents, and it's running right now. And while it's running, what we can do is we can open up the console and actually watch it run. So we can see a graph of this agent at real time. We can see exactly what it's doing. It's getting information from its first big loop is getting a lot of comments from Hacker News. We can peek in and see exactly what comments it's getting. It's now into its second step. And because it's a reliable agent, we can just kill it, go back, restart it, and it's going to pick up from exactly where it left off. And it's going to keep going and keep researching. Okay, it takes a while to run because it's, agents take a while, but we'll come back in a few minutes and see a full report on, in this case, what Hacker News thinks about AI agents. Okay, so that's the end of our presentation. We'd love to just hear what kind of questions you all have for us.
Peter and Chen, somebody asked whether using DBOS can help increase the efficiency of token usage, like prevent tokens from being wasted in the event of failures?
Yeah, definitely. That's a good question. I think that's actually one of the use cases for DBOS, because each step we snapshots, or we checkpoints the steps output, so that if your agent fails in a tool call, when you restart the agent's loop, it will, instead of calling the LLMs again, it will use the recorded results. So you're not going to waste your tokens to call LLMs again. So that's a way to save token usage.
Question for Jacopo and Ciro. Somebody wanted to know exactly when is data replicated in the Git for data example you showed.
The Git for data works like doing like 0 copies of your tables that are stored as iceberg tables. Bauplan automatically versions all the operations. So you have a commit history. So every write operation that happens in your lake is naturally stored in your commit history. So you have like version, you can always do query point in time, like travel back in time, like with both queries, or just like check certain artifact in time, like whenever a write up operations happens on the lake. You don't have to do it, like the system does it automatically for you.
Can you, with durable workflows, can you add new steps dynamically? And I guess that's either like new version of the workflow or I guess conditional steps.
So yeah, absolutely. The nice thing about these workflows is that you write them as code. So you can just write a function that conditionally, you can write a function with an if statement that conditionally calls either step 1 or step 2 depending on its input. You can write a for loop that calls a step as many times as you want depending on its input. And you can also change workflows over. You can also, of course, publish new versions of your code with new workflows if what you originally had wasn't working and you want to write something different.
Yeah, so in DBOS, each workflow is tagged with a version. So we always guarantee that the workflow will complete with the version it started with. And then if you deploy your new code, or if you found a bug in your workflow, you want to restart. And then we provide a functionality called the workflow fork. So you can fork a workflow execution from a specific step, so that after that step, you can fork it to your new version or your bug fix version. And that way, that's how we handle bug fixes and version updates.
Another question for Jacopo and Ciro. Question was really about the about use cases for Bauplan and whether there are certain data engineering tasks or use cases that are better fit for, or worse fit for Bauplan. Like
Yeah,
sweet spot
generally
it.
speaking, like the use cases that we have in place today there's a lot of write, audit, publish. So there's a lot of workflows where people are trying to make very robust the ingestion process of new data in their data lake. There's transformation pipelines a lot, like that is kind of like the bread and butter of our use case. And some of them end up being very left. Some of them are more like closer to the analytics or closer to the preparation of features for ML and so on. I guess like what I would consider a little bit of like if you want like a meta use case, is just like having a lake house. So there's a fair amount of companies out there that either are still like on Postgres or they went for a warehouse right away. And what I would like to do is kind of do a stack that is more future-proof and more flexible based on S3 or object storage large. As Bauplan is a very simple way for folks to just like dump something in S3 and turn that into a platform. So that's one of our like use cases.
Thank you. This one's for Peter and Shen. It has to do with transactions versus workflows. And the question was, maybe just quickly explain the difference between those and DBOS. And then I think there's kind of a bonus question, which is what are the trade-offs for using this, if any, for using the same database for your application data and your durable execution state data?
Peter?
Okay, so the way transaction steps work is they run the step, they run the actual, so transaction steps are only for steps that do database operations. And what they do is they run the database operation in the same transaction as DBOS's checkpointing logic. And what's nice about that is that it means that the entire step and its checkpoints are one atomic unit. So the step is truly guaranteed to execute exactly once. A normal step might be retried upon failure. You might execute it, it fails, execute it again, it succeeds. But a transactional step, it executes exactly once. It either, succeeds and commits and is totally done and checkpointed, or it doesn't succeed and gets completely rolled back. So that's the advantage of these. And then you can use these if you need that really strong exactly once guarantee for database operations in your workflows. Looking at this broader question of when to use the same versus different databases for applications and for durable execution, the big advantage is are these transactions and these super strong exactly once guarantees they provide, and also of course less infrastructure. But The flip side is that often you might want the performance isolation that comes from having separate databases for your application and durable execution data, so that load on one can't affect the other, so that you can separately manage the performance and the load on each. So,
Mhm.
trade-off that's totally up to you in your use case.
Yeah, another thing is, in general, don't put things that are not database related into a transaction, because that will basically hold your database logs unnecessarily. So typically, if you just do external communication, then use DBOS steps and only use DBOS transaction for actual database interactions.
This question is for everybody. The question is whether your pipelines can be executed on serverless platforms like Google Cloud Run, AWS Lambda, Cloudflare.
So the Bauplan is actually a runtime. So it's not like it's not like DBT. It's more like Databricks. So the runtime that you use to run a pipeline is a dedicated runtime based on our work. Is you can think of that as a bunch of functions chained together. So if you want to have a mental model of how you write and execute a pipeline, is going to feel like lambdas. But we had to build that from scratch because for a number of reasons, serverless platforms are not super well suited to run very chunky data pipelines. So, like lambdas are the kind of stuff that you use for stuff like microservices. So you have like, fanning out is your main concern, but the single functions don't necessarily process like, I don't know, a terabyte of data. So when you do like data pipelines, like you need a runtime that accommodates for the quirks of data pipelines. So ultimately, when you do Bauplan Run, you're submitting a job to a cloud executor that is ours, and that is going to run it for you.
Okay. Same question for Peter and Chen.
Yeah, so a DBOS application can run absolutely anywhere. That said, a DBOS application does need a long-running server somewhere in order to detect workflows need recovery and recover them. So that makes DBOS a fit for some serverless platforms, such as Google Cloud Run. DBOS works extremely well with Google Cloud Run. Some of our larger customers actually completely self-host on Cloud Run. But it's less good of a fit for other platforms like Lambda, where functions are very ephemeral and nothing's surviving for more than a few seconds or minutes. So like, the question is, so then DBOS will work on a platform if there's a long-running server around to DQ workflows and to recover workflows. And some serverless platforms have that, some don't.
I got the questions about durable queuing scalability, I guess. At what point, up to what point can you use durable queues in DBOS versus maybe having to think about using Kafka?
Yeah. So DBOS scales with Postgres. So every DBOS durably queued workflow incurs a couple of Postgres writes. It's about two or three. It's at least two, depending on the size of your workflow. Postgres can handle on the order of a large Postgres box can handle on the order of 10,000 of Postgres writes per second. So DBOS scales with Postgres up to several thousand queued workflows per second. Past that, you either have to further scale your Postgres, which you can do by sharding Postgres or using a more scalable Postgres. In that case, DBOS will scale infinitely. Or if you don't want to scale Postgres, or if you have like incredibly high load, then you should start thinking about something like Kafka. So the answer is on a single Postgres, up to several thousand queued workflows per second. Past that, either scale Postgres or use something else.
Okay. And there was another question that just came in. I think you may have just sort of answered it, but they were asking, what kind of planning do you need to do to deploy DBOS at scale? I think you said that it's, since DBOS works within your applications, it's it'll just work at the scale your applications does. And you have to, and then it's really a question of scaling Postgres.
Yeah, it becomes a question of scaling Postgres, and then the rule of thumb is that a large Postgres server is going to be able to handle thousands of workflows per second. So that's like roughly the rule of thumb you should think about when scaling DBOS plus Postgres. But DBOS is as scalable as your Postgres is.
All right, I think that wraps up the, one last question. Sorry, we'll wrap up with this one. How does workflow versioning work?
Mm-hmm. Yeah, I think so. DBOS will automatically compute a hash based on your workflow code, but you can also tag your process with a specific version, and then all the workflows will start running tagged with that version. So yes, you do need the code. You do need to know the code to run your workflow. Yeah.
And then when your workflows recover, DBOS will try to will always recover workflows to a process running the same code version as the workflow. So what that means is that when you want to do breaking changes, when you want to do a big code update includes breaking changes. If you need to recover those old workflows, you likely want to do some kind of blue-green deployment, where you keep around some servers of the old code version. Those will automatically recover the old code version's workflows, drain those, and new workflows will start on the new code version. So that's how you can do breaking changes in your code. And that's all. And the actual recovery to the right servers is all handled automatically under the hood by DBOS.
Thanks again to Jacopo and Ciro for guest starring, and we look forward to seeing you at an event again in the future.
Thank you very much for having us. This
Thanks
was a
for
lot of
having
fun.
us.
This was
Hi, everyone.
really fun talking.
Thank you.
Bye,
Ciao,
guys.
ciao,
Thank you.
everybody.
Bye bye.
Thanks everyone for joining. Bye.
Bye bye.